Hi, GED students. Mrs. L here with our science practice test series for GED. And today we're going to be looking at question number 3. And for question number 3, we have a graph here of salt solubility at various temperatures. So let's take a look at the explanation at the top. A scientist collects data on the solubility of different salts at different temperatures. The results are shown in the graph. Okay, so let's look around here and see what sort of information we have. I see 1, 2, 3, 4, 5 different lines, each a different color on our graph. And over here is the key, and it tells us what each one of those colored lines represents. They each show the solubility data for a different salt. Let's see what else. We've got increasing solubility here on the left, and down at the bottom of the chart, we have temperature. So we are going to be looking at solubility as temperature increases and what happens to it. So which conclusion is supported by the data in the graph? One good test strategy for this is to take a peek at all the answers first. Just kind of skim them so you know what some of your choices are, and then we'll go through them very carefully. So solubility always increases as temperature increases. At 40 degrees, KCl has the highest solubility, rate of change of KNO3, and the solubility of NaCl does not increase. Okay, so I see references to several salts here. So I'm going to highlight those right now just to make that easy. KCl, all right, and up here KCl is green, so we're going to be looking at the green line for that one. KNO3 and KNO3 is blue, so we're going to be looking at the blue line for that answer choice. And NaCl, regular sodium chloride, is the yellow line. So those are the 3 lines we're going to be looking at for different answer choices. Okay, so let's take a look at number 1. Answer choice A. Solubility always increases as temperature increases. Now, whenever you see words like always or never or only, those are very specific. That means there cannot be any exceptions. So let's look at these different lines on this graph. If solubility is increasing, which means going up, as temperature increase, which means going to the right, we will see a positive slope on a line. For example, this red line, solubility is increasing as temperature is increasing. The line is going up. The blue line is also going up. I can see that. So yes, that one is solubility is increasing as temperature increases. The yellow line is not going up as much, but it is going up. The green line is going up, but then we take a look at the purple line. The purple line is not going up. In fact, solubility is decreasing as temperature increases until we get to about 30, it looks like about 32 degrees, and then it stops decreasing and levels out. So answer choice A cannot be true because there's one solubility line that doesn't follow that pattern. So we're going to cross off answer choice A. Answer choice B, at 40 degrees Celsius, KCl has the highest solubility of the salts in the table. So that's potassium chloride. KCl is green. So let's look at the green line. Let's find, I'm going to use my highlighter here so I can find the exact point they're talking about. So they said at 40 degrees. So let's find 40 degrees is here. And we're going to go up to the green line, and that's right there where it intersects the green line, okay? So at 40 degrees, KCl has the highest solubility of the salts in the table. Nope. I see the blue line, KNO3, and the red line, PbNO3 too, have higher solubility at 40 degrees. So it is not answer choice B. Okay, so let's cross off answer choice B here. Answer choice C. The rate of change in the solubility of KNO3 changes as temperature increases. Okay, so rate of change, let's talk about that. If the rate of change is constant, we will be at a perfect 45-degree angles. That means for every 10-degree increase, I'm sorry, let me take that back. We do not have to be at a perfect 45-degree angle, but the line has to increase at the same amount as it goes. Okay, so an example of a line increasing perfectly is this red line. So let me highlight here. So at 10 degrees, we are right here. At 20 degrees, we are right here. At 30 degrees, we are right here. At 40 degrees, we are right here. As you can see, it's increasing in solubility in equal jumps for equal increases in temperature. And this gives us a nice even slope. The slope does not change. If the slope changed, the line would go like that. Suddenly we'd see the slope, and that would be a change in the rate of change. But we don't see that for the red line. However, for the blue line, we do not have a nice even slope here. The slope changes as the temperature changes. And same thing with the purple line. You know, the solubility is decreasing fairly quickly until we get to about this 32-degree point. And then from here on out, the rate of change is constant. It's not changing at all. But from here to here, there was a different rate of change. So the rate of change of this purple line definitely changes as temperature increases. What they want to know is, does that apply for KNO3, this blue line? Yes, this is not a straight even slope. This is not a straight even rate of change. It kind of, it actually, the line, see how the line gets a little more vertical at the top? That means the rate of change is changing more quickly. So answer C looks really good. So I'm just going to highlight that. Let's take a look at answer D though and make sure we can rule that out. The solubility of sodium chloride NaCl does not increase with increasing temperatures above 80 degrees. Let's find 80 degrees, and NaCl is the yellow line. So 80 is here, we go up. Here's the 80-degree point, and as we go up from 80 degrees to 90 degrees to 100 degrees, the solubility is increasing, not by a lot, but it is increasing. And so therefore, answer choice D cannot be true because we do see an increase. So our correct answer then is answer choice C.